Okay, so we'll take up number 14 really quickly. You guys got a chance to try this right now. First step, standard form. Is this in standard form? Yes. X squared term, x term, constant. So good. Second step, I have to factor out the a in the first two terms. What's my a value right here? Not just 1. -1. So my a is -1. So factor a -1 out of the first two terms. So divide this by -1, divide this by -1. When you divide that, you get x squared. I caught a lot of people make this mistake. What is this? 2x divided by -1 is? -2x, not plus. So I saw a lot of you guys made that mistake. Okay. Third step, I'm going to take half of my b, which is -2, half of b, which is -2, divided by 2, and then square it. -2 divided by 2 is -1. So when I square it, I get 1. So +1, -1. Oops. Okay, and then don't forget the +3 is still there. Okay. And fourth step, multiply the fourth term out. Oh, sorry. That's not it. That's not there. Multiply the fourth term out. So the -1 times -1 gives you +1. Good. So bringing it out of the bracket means I have to multiply it out. So I get the +1. And then +3. So y equal -1. And then here, this is a perfect square. Perfect square. So it's x plus something or x minus something. What is this number? Sorry? Not just 1. -1. This right here. That's why I wrote this on the side. That number goes right here. Okay? That's why I say this is a very important step. When you do b divided by 2, that's what goes in here. So x minus 1 squared plus 1 plus 3. So your final answer, y equal -x minus 1 squared plus 4. Okay, I just add up the last one. Okay, in this case, what is my vertex? 1, 4. Okay, but what so the good thing was, when I went around, a lot of you guys put the +2x, and then right here you got that x plus 1, which then you guys wrote, oh, that means my vertex is -1 and 4. And then when you did your therefore statement, you recognize that you did something wrong because you can't have a negative value right there for your word problem. So good recognition that you realize that you did something wrong. That's when you should go back to check to see where you messed up with the signs. Okay. Looking at the question was asking, a diver dives from the 3-meter board at a swimming pool. Her height, y, in meters above the water in terms of her horizontal distance, x, in meters from the end of the board is given by that. What is the diver's maximum height? Okay, so if I were to draw a quick little sketch, she dives off a 3-meter board, and anybody swim here? Alright, so when you jump off a diving board, do you go like that, like straight down in the water? How do you jump off a diving board? So let's say this is the diving board. You jump upward first and then come down. That's right. You don't go just like that. You won't get much points if you just fall. That's not jumping off the board, that's falling off the board. So when you jump off the diving board, that's what it looks like. So that's why your vertex is right here at 1, with a maximum height of 4. All right. So it's the question was saying when did the person reach this maximum height? So after 1 meter away. So the maximum height of 4 meters was reached after 1 meter away from the diving board. Okay, so when you guys did your therefore statement and realized that one of your numbers was negative, you recognize that something was wrong. That's why in a word problem, concluding sentence is very important because it helps you catch your mistakes. It makes you think, does your answer make sense? Okay. Usually x-axis we use time. But in this case, they use distance away from the diving board. So that's why it sounds a little weird, but that's what it means. If x was represented by time, then your therefore statement might be the maximum height of 4 meters was reached after 1 second, for example. Okay. All right, so that was number 14. Number 16. Number 16 was it was very tricky. Okay. We will do more of these later on. Thursday's lesson is dedicated to just word problems. Okay, so you guys can have more practice on these. So right now it might seem very hard, but after a couple more times it will make more sense. Okay, so number 16 says you can sell 120 ornaments if you price it at $4. Okay. If I decrease the price by 50 cents, I can sell another 20 ornaments. Okay. So, and in this case, so if I want to figure out how much I can make, I can just simply do 120 times 4, which is 480, right? If I 120 ornaments, $4 each, I just times this, I get my revenue. But here, it's saying every 50 cents decrease. So how do I change this up so that I can write it's every 50 cents? Yeah, add an X onto it. Good. For every 50 cents decrease, so I'm going to do that, I get to 20 more. For every 50 cents decrease, I get 20 more. So how do I change this up? Yep. And the sign? Plus, yeah, because there's more. Right. So instead of just doing 120 times 4, my equation is now going to be 120 plus 20x times 4 minus 50 cents x. Right? So revenue. So originally, if it was just $120 ornaments for $4 each, I know that I could just multiply it like that. But because I'm adding on this new condition, that's why my equation changed to this. Okay. So what is x? If I were to write a let statement, let x represent what would x represent? This is the tricky. This is the most important part, but it's also tricky. Not the number of ornaments. Any ideas? Throw out your ideas. What do you think x represent? Okay. Okay. So you guys are just looking at the cause and the ornaments, but here x actually represents. If you look at the question again, number 16. Okay. For each 50 cents decrease in price, you can sell 20 more. So for each 50 cents decrease, so your x represents number of deduction, price deduction. Number of price deduction. Okay, let x represent number of price deduction. So, does it make sense now? Like how, now that you know what x is, this makes sense. So, we want to complete the square. What was the very first step that we have to do in completing the square? Sure. FOIL, right? Because the first step was it has to be in standard form. This is not standard form. This is factor form. So we have to do FOIL. First, outside, inside. Last, do FOIL to write it in standard form. So 120 times 4, you get 480. 120 times negative 0.50x is negative 60x. 20x times 4, you get plus 80x. 20x times negative 0.5x, you get negative 10x squared. Okay, so I have 480 plus 20x minus 10x squared. Right, is this standard form? No. Right, remember x squared term, and then constant. So rearrange it. Negative 10x squared plus 20x plus 480. Okay. Now we can complete the square. So by now, I think you guys know the steps. So take out the a. So you get x squared minus 2x, and then plus 480. Remember, you're only factoring it out of the first two terms. Even though I can this is factorable, I don't factor it, I leave it. Okay, and then I'm gonna take half of b. So again, negative 2 divided by 2 squared, negative 1 squared. So it's 1. What are the odds? both example is just 1. So you have plus 1, minus 1, and then plus 480. Okay. R equals negative 10 x squared minus 2x plus 1. Bring this negative 1 out by multiplying it with the negative 10, which gives you plus 10. Okay, so R equals negative 10 x squared minus 2x plus 1. Oh, sorry, I forgot to factor this. This is a perfect square factor. Right? Okay, what do I put inside the bracket? X minus 1, right here. Okay, and then here, when you add it up, it's just plus 490. So my vertex in this case is 1, 490. Okay, so does that mean I should set the price of the arguments as $1? So if it's $1, I'm going to make $490. Is that what it means? Okay, how many? You're right. It's not. All right, so what is this 1? What did we say 1? What did we say X represent? Right. So remember right here, we said let X represent the number of price deduction. So that means we should have 1 price reduction. Originally, it was $4 with 1 price reduction. How much should we set the cost to be? $3.50. 1 price reduction, that means we should set the price to $3.50. Right, remember right here, we said that for every 1 price reduction, we can sell 20 more. And we were trying to figure out how many price reductions should we do to sell the maximum. And in this case, it was $3.50. So if I were to write my therefore statement, therefore, the price of $3.50, the price of $3.50 will give a maximum profit of, how much would you make if you set it at $3.50? Which is $4.90. That's right. Okay, so this is your, so if I were to do a quick little sketch of the graph, it'll look something like this. Okay, where this is 1 and this is $490. $490. Okay. If I set it, if I have too much price reduction, people are not going to buy it. And then if I have too much price reduction, then it's not going to cover my costs. So then I don't make as much money. If I don't make price reductions and I increase my price, nobody's going to buy it, and I actually lose money as well. Okay, so that's what your graph looks like. All right, so this question was hard because you were not given the equation. So number 12, 14, and 15, you guys were able to do it because the question gave you the equation. And all you had to do was complete this part. Will you get questions like this, where you have to come up with the equation? Possibly. Okay? But we'll do more practice on these. This is as tough as you'll see on the test. Okay? Okay, so. And she just needs one. Thank you. Thank you. Okay, so solve by factoring. So let's say you're given this and I want to factor. I want to factor that. Well, I can't because I have x all over the place. I have things on both sides. So let's move everything to one side first. 6x squared. Move this over. Move this over. So when I move those over, I change the sign. 2x minus 3x is negative x. 15, when I move it over, is negative 15. Okay, on the right side, it equals 0. If it's an equation, it's still an equation after you move stuff. So you still have that equals 0 on the right side. Don't forget that. So based on this is factorable. So remember the method that we used in chapter 4? How do we factor this? 3x times 2x gives you 6x squared. Negative 5 and 3, when you cross multiply, you get 9x minus 10x, which is negative 1x. Okay, my middle term. That's what we wanted. Is this coming back to you? Maybe. Okay, we did this, and you guys did really well in that chapter with factoring. So when we write it, this was my first bracket, this was my second bracket. Remember that? Yeah, so we have 3x minus 5 and 2x plus 3. Right? Okay. In chapter 4, we stopped right there. That was our answer. All right. Now in chapter 6, we're going to actually solve for x. We have to figure out what x is. All right. Remember, my equation right here is equal to 0. So what's 100 times 0? What's 1,000,000 times 0? What's 0 times negative 1,000? 0. Okay, thank you. Say it with confidence, guys. You know it. Okay. So anything times 0 is 0. So I'm trying to figure out for what value of x would make this equal 0. So 3x minus 5 equals 0. I'm trying to figure out what x is, so that when this is 0, that means the whole thing is 0. Okay, so how do I solve this? How do I solve for x here? What do I move? Equal? Yeah, so 3x equals 5. And so x equals? Yep, 5 over 3. Okay, so if you look at it, okay, well, when x is 5 over 3, 3 times 5 over 3 is 5. 5 minus 5, you get 0. Okay, that's what you're trying to figure out. That's why we set it to 0, so that we can figure out what x value it is. Same thing on this side. I'm going to set 2x plus 3 equals 0. So what do you guys get for x? Yeah, Aman?
3 over 2.
Not just 3 over 2.
Negative 2.
Yeah, good job. When you move that 3 over to the other side, don't forget to change the sign, so it's negative 3 over 2. Right. So there we go. We found our x-intercepts. When we graph it, negative 3 over 2 and 5 over 3. Those. So my parabola looks something like this. Okay, so what we just found were the two x-intercepts. Okay. Now this was easy to do because the integers work out nicely. If you think back to chapter 4, were all the numbers always nice? Remember, there were ones that were not factorable. You couldn't figure out what to use to make it equal to the middle term. So there were times where like it was not factorable. It didn't work. You scratched your head for like 10 minutes and you couldn't figure out what the combination was. Well, now we have what's called the quadratic formula. Quadratic formula will always work, even if it's a decimal. All right, quadratic formula. x equals. Anyone know what the quadratic formula is? Right?
Plus minus b squared minus 4ac and squared root. It's the thing from the challenge question, right?
Kind of. Over 2a. Good job. Okay. This formula, don't kill me for it. Yes, you do need to memorize it. It's not too bad. After you do it for like 20 times, you'll remember it. I did it for 15 years. I memorized it.
I remember it long enough to do it 10.
All right. You will need this. You'll need it next year. You'll need it in grade 12. You'll need it in university. So remember this formula. It's actually not too bad. Just a lot of ABCs. Okay. Remember it, remember it, remember it. If you make it your own formula, you're screwed. So don't make it your own formula. Remember the formula as is. Memorize it. Okay. So if you're thinking, what is A, what is B, what is C? It's the in standard form. So this was your standard equation, right? 6x squared minus x minus 15. So it's the coefficients right here, and right here. Those are your A, B, and C. What is A? What's my coefficient here in front of the x squared? There, I'll move it up. What's my coefficient? 6. What's my B? Sorry? Think again. -1. That's right. Negative. So it's -1. And so C is -15. Good job. Okay. So now I can sub everything into the formula. Now when I substitute, what do I need around that number when I substitute? Whenever I do substitution, I need brackets. Thank you. Very, very, very important in this case. Okay, so negative, there's a negative right here. It has nothing to do with B being positive or negative. That is an extra negative sign. So -1, put that in bracket, plus or minus square root b squared. So b again is -1 squared minus 4 times a, which is 6, times c, which is -15. All over. Yeah, and people like to forget about the denominator. 2, and then a is 6. All right. So I substituted my A, B, and C into the formula. I purposely used a different color because I want you guys to know this negative is part of the formula, not part of your B. This plus and minus sign, this -4, this 2, all part of the formula. So I want you guys to make sure you don't mix up the signs. Okay. So x equals negative times -1 gives you 1. Plus or minus square root. Do this part in your calculator. This is all just numbers. So it looks like a whole bunch of numbers, but it's better than having a bunch of variables. So -1 squared is 1 minus 4 times 6 times -15, and you get 361 over 12. Okay. Square root 361 is actually 19. Okay, so you can do this, you use a calculator. Square root 361. You get 19. So you have 1 plus or minus 19 over 12. Okay. This right here, right, okay, plus and minus means two separate. Just like right here, how many x-intercepts did I find? 2. That's why right here you have a plus and minus to give you your 2 sets of answers. One of them is going to be x equals 1 plus 19 over 12. And the other side is going to be 1 minus 19 over 12. Okay, so you see one side is a plus sign, one side is a minus sign, so that you get your 2 x-intercepts. So x equals 20 over 12. When I reduce that, that's 5 over 3. On this side, 1 minus 19 is negative 18. Negative 18 over 12. When you reduce it, I get negative 3 over 2. Now, where did we see these two numbers? Where did we see these two numbers? Ta-da! Up there. Okay. So, there you go. You found two methods in solving for x-intercepts. If it's factorable, do the factor way because it's faster. But if it's not factorable, or you can't think of the combination, or if it's a decimal, then do the quadratic formula, and you'll get the same answer. Yeah? Not yet. I'll stay for the lesson. We'll do another example with the quadratic formula, but does this make sense? Are we okay with this? Okay, we'll do another example. The path of a stone thrown into the ravine is multiplied this quadratic formula, just like what we just did. Where x represents the distance in meters traveled horizontally and y represents the height in meters above the surface of the river at the bottom of the ravine. How far does the stone travel horizontally before it hits the water? Okay. So I'm trying to figure out this point right here. When does it hit the water? So am I trying to find my vertex or am I trying to find my x-intercept? X-intercept. And so if I'm trying to find my x-intercept, should I do complete the square or quadratic formula? Quadratic formula. Okay, good. So here's my equation. Okay, so what's A, what's B, and what's C? A is, B is, C is. Perfect. Okay, substitute it into the formula. Try it. Okay. Once I get to this part, how do I set up my 2 equation? My first one is going to be x equal so Corin over -2. Good job. And then the bottom one would be -5 minus 19 over -2. Don't forget your denominator is -2 in this case. Okay. So when you solve, you get -7 and you get 12. Okay. How many of you got -7 and 12 as your 2 answers? No? Did you get -7 and 12? Oh, okay. I didn't see you put your hand up, so I thought, oh, you didn't get it. Okay. But does that mean, did I answer the question? Does that mean that those are my answers? Yeah, good. You know me well now. I taught you for 2 months. You know when I ask like that, it's probably no. Okay. What's wrong with my answers? Why can't, which one seems to be the weird answer? Okay, well, remember we are looking for this right here. How many? The -7. Yeah, -7 is all the way back here. So think of this as like a cliff, okay, where it's like rocks. I can't throw the stone backwards. It's not gonna go through the rocks, right? So this answer, that's negative, we're actually gonna reject it. We're gonna reject that answer because it doesn't make sense. Or, let's see. So, like that. This answer is this right here. What's my unit? Meters. Right, it's this right here, meters. Okay, and horizontally by meters. So my therefore statement is going to be therefore the stone traveled 12 meters horizontally before hitting the water. Okay. Oh, sorry. Let me move this over. So it's not the path of the stone traveling 12 meters. It's the horizontal distance. In grade 10, you will not be able to find the distance of this curve yet. You'll find the distance of this curve in like maybe grade 11 or 12. Grade 10, we only know how to find the horizontal distance this way. Okay? Are we okay with why we're rejecting the negative answer? Okay. Now, does it mean every single time if it's a negative answer, we reject it? No. It depends on the question. Right. So there could be questions where you would take both answers. There would be questions where you would reject one answer, or there could be questions where you reject both. All right. So be careful. Make sure you read the question and make your therefore statement to know whether you should take it or reject. Okay. 2 more examples. And I'll give you guys time tomorrow as a catch-up period. I think we need a catch-up period. Okay. Example 3 right here. The rectangle has an area of 1150 centimeters square. What are its dimensions? Okay. So area of a rectangle is length times width. All right. So my length right here is 3x plus 1. My width is 2x minus 5. I know the area. My area is 1, 1, 5, 0. Right? A lot of people, once they get to this, they would, oh, I see my 2 brackets. I can do my 2 arrows and then solve. Right? Can I do that? Why not? Why can't I just, it's factored already, isn't it? Isn't factored. I see the 2 brackets. Why can't I just do the 2 arrows and solve? Yeah, I find the x by doing this, but why can't I do this? Compare this to what we did right here. What's the difference? Why this one, I can do my 2 arrows and solve for x, but this one I cannot. Yeah. It doesn't equal 0. It's equal 1, 1, 5, 0. So I cannot. I've seen it so many times on the test where people just went straight to the factoring. So I can't. So what do I have to do to make it into standard form? FOIL. First, outside, inside, last. I have to do FOIL. So 1, 1, 5, 0 equals 3x times 2x is 6x squared. 3x times negative 5 is negative 15x. You get plus 2x, and then multiply that, you get minus 5. Right? As Taisha said, we need it to equal 0. So we're going to move everything to one side. 5 minus 1, 1, 5, 0. All right, so now everything is on one side. I moved this over. So technically 0 equals that, but your 0 can be on either side of the equal sign. It's the same. All right, 6x squared minus 13x minus 1, 1, 5, 5 equals 0. Okay. So there we go. We have the standard form now. So A is 6, B is negative 13, C is negative 1, 1, 5, 5. All right, substitute it into your quadratic formula. So try it, substitute it in. Be careful with the negative signs. Okay. How many of you got 15? What's one of your answers? Okay, I see that some of you are still working on it. Okay. So if you did it correctly, 15 would be one answer. Negative 12.8 would be the other answer. Okay. Now, since this is a word problem, I may or may not take both answers. Okay, so we have to check. Okay. Look at the question again. What did the question ask? What is the question asking? What are its dimensions? So, can I have negative dimensions? No. So I'm going to reject this answer. I'm going to take this answer, but that's still not my answer. It was asking for the dimension. What am I going to do with this x equals 15? Yep. Plug it into here. So 2 times 15 is 30. 30 minus 5. So this side is 25 centimeters. Same thing right here. 3 times 15, 45. 45 plus 1, 46 centimeters. So this rectangle has dimensions 46 by 25 centimeters. And if you want to check to make sure that it is correct, 46 times 25, 1150, which is correct. Okay. Question on example 3? Yeah.
If you use x equals negative 12.8, would you still get the same answer?
No, because if you plug in negative 12.8 in here, 2 times negative 12.8 minus 5, you'll get a negative dimension. And so that's why we rejected this. But you won't know unless you plug it into the thing, because sometimes it could still work. Good question. Okay, last example right here, and then we're done. And then I will give you guys class time tomorrow to work on the homework. What does the word root mean again? Yep. X-intercepts. So what they're saying is x equals 1/3 and x equals negative 3 over 2. So they tell you that those are your two x-intercepts, just like right here. So they tell you this, they want you to come back to this, basically. They want you to work backwards. All right. So if these are my two x-intercepts, that means I can rewrite these two bracket as x minus 1/3 and x plus 3 over 5, right? Equals 0. Okay, so like those are, we're doing the arrows backwards, basically. We're doing the arrows backwards. It wants it in standard form. So I'm going to multiply each of these terms. Multiply by doing FOIL. Multiply, 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 multiply. So x squared, x times 3 over 5x is 3 over 5x. And then I have negative 1 over 3x. And then minus 1/3 times 3/5. 1/3 times 3/5, you get 1/5. Because the 3's cancel out. Okay, so what I did here was I just did FOIL. Remember when you multiply fractions, you just multiply the top number with the top number, bottom number with the bottom number. So that's how I got 3 over 15, which is the same as 1/5. All right. Is this standard form though? Why not? Fractions, right? Because of the fractions. That doesn't make it standard form. So remember the trick that I taught you guys of last few weeks ago. If I don't like fractions, what can I do? How do I get rid of all the fractions? Yeah. Multiply everything by common denominator. What's my common denominator here? 15. So multiply everything by 15. So 15 times x squared, I get 15x squared. 15 times 3, 45. 45 divided by 5, I get 9. Negative 1 times 15 divided by 3, I get negative 5. Negative 1 times 15 divided by 3, I get negative 3. Don't forget on the right side, 0 times 15, you get 0. And so lastly, I can just simplify these two terms. So my standard equation now, 15x squared plus 4x minus 3 equals 0. So this is working backwards. Given the roots, find the equation. So we did that, we put it back into the brackets, and then we did FOIL. After we do FOIL, we can multiply everything by the lowest common denominator and clean it up, we get that. Okay, so I know we did a lot today. My lesson video today was 52 minutes. This is like record high. You can start on some of these. Tomorrow, I'll give you guys the work period. All right. Work period for catching up yesterday's questions and tonight's question. But do get a head start on this so that tomorrow you can know what you are struggling with, and then you can ask me. Okay. Thank you for your patience, guys. You guys did great. Try the homework. You'll have class time tomorrow.